Synthesis and reactions of beta dicarbonyl compounds. Introduction. Compounds having two carbonyl groups separated by an intervening carbon are called beta dicarbonyl compounds, and these compounds are highly versatile reagents for organic synthesis. This is an example of a beta dicarbonyl compound system, that is acetyl acetone, which contains two methylene hydrogen atoms which are acidic in the range between 10 to 14 in the pKa scale. Another one compound is a beta ketoester. It also contains a methylene group which is also acidic. Then a malonic ester also contains a methylene hydrogen atoms which are found as acidic. The Claisen condensation. The synthesis of beta ketoesters is normally done by the Claisen condensation. When ethyl acetate reacts with sodium ethoxide, it undergoes a condensation reaction. After acidification, the product is a beta ketoesters. Condensations of this type occur with many other esters and are generally known as Claisen condensation. This is a model reaction for Claisen ester condensation, in which ethyl acetate two molecules of ethyl acetate react to form ethyl acetate in the presence of the sodium ethoxide catalyst. This ethyl pentanoate again reacts with ethyl acetate to form the beta ketoesters and in 77% yield. General reaction. The general reaction is being carried out with the help of sodium ethoxide and ethanolic medium to form the beta ketoesters. The reaction mechanism of ethyl acetate occurs by this way, in which first sodium ethoxide attracts a proton to the ethyl acetate. Then the second step involves the carbon ion formed again reacts with the carbonyl carbon to attach to form an alkoxide ion. That alkoxide ion then takes up a proton to form the ethyl acetate. It is of a simple synthetic use. The intramolecular cyclization reactions yield a 5-membered ring ketone as well as ester group. Diethyl heptane diet also undergoes cyclization in the presence of sodium ethoxide to form a cyclohexanol derivative. Cross-Claisen condensations are also possible. Cross-Claisen condensations are possible when one ester compound has no alpha hydrogen and it is therefore unable to undergo self-condensation. So, ethyl benzoate and ethyl acetate reacts in the presence of sodium ethoxide to form ethyl benzoyl acetate in 60% yield. Ethyl phenyl acetate and diethyl carbonate again reacts in the presence of sodium ethoxide to form diethyl phenyl methanolate. Ethyl phenyl acetate and diethyl acetylate undergoes Claisen condensation in the presence of sodium ethoxide to form a derivative. It is mainly useful for acylation of other carbon ions. Here, a cyclohexanol moiety is thus deprotonated in the presence of sodium ethoxide, and it is again reacted with diethyl melanate, and this diethyl melanate group get attached with the cyclohexanol group. In knoevenagel condensation, active hydrogen compounds condense with aldehydes and ketones from knoevenagel condensations. Those aldol-like condensations are catalyzed by weak bases. An example is benzaldehyde reacts with diethyl melanate in the presence of diethylamine and ethanolic medium to form a derivative, which again undergoes a knoevenagel condensation type reaction. Michael addition. Michael addition is the best example for this knoevenagel type of condensation reaction, in which diethyl melanate and 1,4-alpha beta unsaturated carbonyl compound react to form a saturated diester in the presence of sodium ethoxide and ethanol. Actually, the melanoritrile and diethyl melanate also undergoes Michael addition in the presence. Michael addition to form a cyanoacidic derivative. A Mannish reaction. Active hydrogen compounds react with the formaldehyde and a primary or secondary amine to yield compounds called Mannish bases. The Mannish reaction is of important use in the synthetic organic chemistry. A simple example is acetone, formaldehyde and diethylamine react in the presence of HCl to form a Mannish base. Okay, thank you.